Hello geometry students. I am not in class today, as you can tell. So you're watching this video. This is going to be a review for you for the Module 3 exam, the one that has to do with using using proofs and being able to make sense out of proofs. Okay. For this exam, you're only going to be taking the part 1. All right, part 2 I am excusing for this module only. Okay, there are going to be 9 multiple choice questions on this exam. I think it's going to be 50 or 60 points. I believe it's 50. So it's going to be sort of like the other exams that are part 1, and it will be auto graded, and so you'll be able to see what your grade is as soon as you take it. The third bullet point, I want you to all make sure that you understand this and that you do this before you try to take the exam. Make sure you have all the proofs from 3.01, which are line and angle proofs, 3.02, which are triangle proofs, and 3.04, which are parallelogram proofs, available to you, which means you write them down, or you go through the Brain Honey lesson, take screenshots, put them into a document, or just know where they're located even. If you can do that, because you're going to want to have those open and you're going to want to be looking at those proofs as you take the exam. A lot of it is just, a lot of the questions in the exam are answerable if you see the proofs as they're supposed to be written and then compare them to what's on the test. Okay, and so that's my biggest advice to you for the test, is to do that. All right, I'm going to put some questions out here. This is going to be about a 15-minute video, which the substitute teacher will be stopping. We'll be pausing to give you guys a chance to answer the questions. It's actually going to be fairly compacted, but the teacher should be able to pause the video and let you guys try to answer the questions as we go along. All right, if you're watching this from home and you have a copy of it, you can certainly pause it, try to answer the questions, and then press play. Okay, question number 1. We have 2 intersecting lines that intersect at point T. Which statement below A, B, C, or D is used to prove that angle PTR is always equal to angle STQ? You might want to pause the video at this point. Okay, the answer is B. Angle PTR and angle PTS are supplementary angles. Now, notice that the 2 angles that you see there are vertical angles. PTR and STQ are vertical angles, and so you need to see that or check the proof that vertical angles are congruent, and that would be located in 3.01. All right, they're specifically written out, and if you read that proof, you will see that there is a line in there about 2 angles being supplementary angles, and that's your answer. Okay, and hopefully if you have any questions you can contact me about that. Let's take a look at question 2. Okay, Maria drew 2 parallel lines, KL and MN, that are intersected by a transversal PQ as shown below. Which theorem could Maria use to show the measure of the angle KRQ is equal to the measure of angle PSN? You can pause the video. The answer to that is B, alternate interior angles theorem. If you draw these things out, if you kind of make markings of the angles as they are written, KRQ is located here, and PSN is this angle. Okay, A lot of times it helps to draw the diagrams on paper and then mark it up, and then once you do that, excuse me, it might be easier for you to see what the angles actually look like. But these are clearly alternate interior angles. Make sure that you remember what corresponding angles are, alternate interior angles are, alternate exterior angles are, same side interior angles, same side exterior angles, and vertical angles, straight angles, adjacent angles. Make sure that you know all of those things. All right, let's go to question 3. All right, look at the picture shown below. All right, looks like we have a line and we have a perpendicular line that goes, line segment that goes with it. Which step could be used to prove that point P is equidistant from points R and Q? Okay, so from the diagram we can assume that segment RS and segment SQ are congruent because of the markings. Okay, which step would be used to prove that point P is equidistant from points R and Q? And you can pause the video. Okay, now this one's a little bit tricky, and I'm going to tell you the answer is B on this one. Although I find this one to be a bit of a trick question because answer B is actually a combination of two statements. All right, because basically what you're doing is you're showing that triangles are congruent by side angle side, and then you can say that PR is congruent to PQ by CPCTC. Okay, now before you even get to that point though, one thing that you probably ought to do, since they're saying point P is equidistant from R and Q, is to actually draw those lines in. And when you do that, when you draw in PR and PQ, you will see that you have formed two triangles. And hopefully by this time that should kind of jar something in your memory that tells you that we have two triangles. One way to show that two segments or two lengths are the same is to show that those two triangles are congruent. All right, and we are given, we're already given a pair of sides that are congruent. We can assume that two 90-degree angles are congruent because they are. And then we also have a third side, PS, is congruent because it's congruent to itself. It's a shared side with both triangles, so by the reflexive property, that side would be congruent to itself. And so you can say that the two triangles are congruent by side angle side. Okay, PRS and PQS are congruent by side angle side, and therefore we can say that segment PR and segment PQ, which actually weren't originally drawn in the first place, are congruent by CPCTC. Therefore, the last step would be that P is equidistant from R and Q would be your last step by definition of congruency. All right, so that one is a little bit of a trick. There's a little bit of a trick. The other three answers in that one would not work though. And so B is the best answer for that one. All right, parallelograms, question 4. The figure below shows a parallelogram ABCD. Side AB is parallel to side DC and AD is parallel to BC. We have a statement. A student wrote the following sentences to prove that parallelogram ABCD has two pairs of sides, opposite sides that are equal. And you can read that. And I'm going to have the teacher pause the video and see if you can come up with the answer to this. Okay. This is one where this is one we actually did in class. All right, we didn't do it as a paragraph proof, but it was done in class. So we have the opposite sides of a parallelogram, our congruent proof, in the lesson, and also it's in the Brain Honey lesson as well. All right, now the order of the statements can be in slightly different order. Okay, so if we take a look over here, this was the proof that we did in class, and some of you may remember that. Okay, and if you number the statements, I have them numbered from 1 to 8. As we run through the paragraph proof, we have a lot of these things are kind of written in. 1, 2, and 3 are kind of in there already. Statement 4 is actually after statement 5 and 6 in the paragraph proof, but that's not a big deal, because statement 4 can go after 5 and 6 because they're not related statements. Okay, and so you can put that one below 5 and 6 and it'd still be okay. All right, but what I'm doing here is I'm just kind of comparing the paragraph proof to the statements in the proof in the Brain Honey lesson. Okay, and then once we get down here, we can kind of figure out that the two triangles are congruent by, and we go down to the proof that we did in class, and we can see that the two triangles are congruent by ASA. All right, so see how I am putting the two proofs together and figuring it out that way. And it's really not any more complicated than that. It's actually not too hard to do once you have the two things side by side with each other. Most of the problems you'll be able to figure out. Okay, but angle side angle would be the correct answer, so it'd be A. All right, let's go to the next question. I think this might be the last one. A figure below shows a rectangle ABCD having diagonals AC and DB. Okay, Jimmy wrote the following proof to show that the diagonals of a rectangle ABCD are congruent, and statement 3 is missing, so we have to fill it in with that statement. Give you a moment. I'm going to have the teacher pause, see if you can come up with that. Try to find the proof for diagonals of a rectangle are congruent in your Brain Honey lesson. Okay, one thing that you might want to do when you are working on proofs like this, where you're actually looking at two triangles that are overlapping, you might consider doing something like this, where you actually pull those two triangles apart and relabel them. Okay, sometimes when you have something like this, where you have 2 or 3 triangles in one or more, that can be kind of confusing to try to keep track of. But if you pull them apart, it becomes a lot easier, and you can kind of focus on the things that you need to focus on. Okay, so the proof for this, what you are looking at is you're looking at two right triangles. The left triangle, that's the right triangle. Left right triangle, that makes a lot of sense. And then the right triangle. Okay, opposite statements are given to us. Or statement 1 lets us say that that's true, given that we have, since it's a rectangle, we have 90-degree angles, so we can say that this angle here is congruent to this angle. So then statement 3, you notice that it has a shared side, DC. So we can say that DC is congruent to DC because of the reflexive property. And so the correct answer for that is C. I hope this was helpful to you. You know, the main thing is make sure you have all those proofs in hand. Okay, and then you can look at them. And if you can do that and kind of go side by side and compare them, I think you'll do okay on the exam on Friday. Okay, thank you, and have a good rest of the day, everyone. And get your material ready for Friday. Have a good day, everyone.